that is the end of the break, so let's continue our course today. So before the break, we introduced how to use array, especially 1D array as argument. And we talked about how to write down the function code. So if array is the argument, or if the array is one of the parameters, when we provide the corresponding argument for the array parameter, we just need to provide the name of the array instead of this. And we also talked about that because in C, function the function has no way to check whether we pass the correct length of array or not. So we can actually use this fact to control how many elements I want this sum array function to sum. So I can just write down 50 here. So the return value from the sum array will be the sum from the first 50 elements of the array. And before the break, we will talk about more about array arguments. So actually there are another very important things about using array as argument. So that thing is that a function is allowed to change the elements of an array parameters. So this means that the change to the array parameter will be reflected in the corresponding argument. So this is very different from the ordinal arguments and parameters. So let's check out the example here. So for example, we can write down the function like this. So we have the function called store zeros. And what this function, the purpose of this function is to modify an array by storing 0 into all the elements of that array. So we can write down the function like this, like store 0 here, and the parameter will be the array that I want to assign 0 to all the elements of the array A, and then I use the parameter n as the length of the array. And let me close that window first. Okay, much better. Okay, so we can see that in the function body of this function here, I have a for loop. I have a integer for the for loops here. So what this for loop do is to traverse the elements in the array A, and then I just assign 0 to it. And then in the main function, I can just call the store 0 function like this. And then after we calling this, and then if we use another for loop to print all the value stored inside B, we will find out that the value stored inside B are actually be modified, and then all the elements have 0 values. So what this means is that the change to the array A in this store 0 functions, all the change can reflect back to the arguments, that is array B. So why we can do this, why array parameter, array argument have such magic power? So this is also hard to explain here, but it is important to let you know if you have this, you want to create this kind of function, you can use array argument to achieve this goal. But the actual reason about why array have this power, we will explain that in the pointer and array. So that will be a few next few weeks. So it will be really hard for me to explain why this happened right now. But now you can remember. So what you need to remember right now is to know that if we use array as parameters and argument, this spatial type of arguments, all the change you do in the function will reflect back to the array you use as argument. So the change to the parameter A will reflect back to the argument B. So the previous example is about using 1D array as parameter and argument. In this example, I want to show how to use multi-dimensional array as parameter and argument. So if we have a parameter that is multi-dimensional array, like in this case, I have a 2D array A, only the length of the first dimension can be omitted. So that means that you can only leave the first bracket empty, but we need to provide the length of the second dimensions. So in this case, that means that if we need to provide the length of the column, we need to tell the function the number of columns. So in this case, in this example, I revise the sum array into this sum two-dimensional array function, and A is a 2D array. And you can see in the function definition, I need to specify, I need to tell the function explicitly what is the length of the column. So I need to provide 10 here. So what this function can do is to process any like 2D array as long as this 2D array have the column of 10, have 10 columns. So that is the revised version of the sum 2D array function. And we can also use another type. We can use also the variable length array as parameters. So if you forgot, variable length array is that the length of the array is determined by another variable. So we don't need to provide the fixed length of that array. So if we have this kind of array that is called variable length array, so we can write down, and so this is the sum array we have previously, right? So there are some drawback in this version of sum array. That is that if we just check out the lines here, if we just check out the array definition here, there is actually no direct link between the parameter n and the length of array A, right? So you need to check out the function bodies to know that, okay, these parameters is used as the length of array A in the parameter here. But in the parameter list here, there's no clue to tell us that n is used as the length of array A. And so there's another way if we want to explicitly show that the parameter n is used as the length of array A. So we want to make it explicitly. We can revise the sum array from this to this. So the first change is that I move the n from the second parameter to the first parameters, and for the second parameters, the array ends, I put n inside here to indicate that n is the length of array A. So the order of parameter list is important here. So if I want to have a variable length, I want to make A as a variable length array, I need to write down the parameter n first, and then I can write down the parameter A, and then use n as the length of array A. So that is the important modification you need to do if you want to set up the direct link between n and array A in the parameter list. So why we want to do this? So the benefit of doing this is that you can that the function note clearly that n is used as the length of a. So the a you provide here need to have the exact length indicated by n. So that means that you cannot like write down we cannot have the example like this. Like we cannot provide the array B and then provide the number that is not the actual length of array B. So this sometimes can give us flexibility, but you can imagine that for some example, maybe you don't want the user of your function to do this. You want the user only provide the length of array, that is the actual length of the array in the argument. So if that is the case, you can revise the parameter list of your function to be like this. So you can force the user of your functions to provide the array that have the length you indicate here. So in general, the length of variable length array parameter can be any expressions. So we can put the arithmetic expression here to indicate the length of the array C. So what is function? So I won't introduce the function body of this one, but I just want to show that you can write the parameter list like this. So this function is to concatenate two array A and B. So concatenate means that you just connect two functions together, like 连接. So you want to attach B to array A, and then you want to store the merged function into, you want to save the merged array into array C. So this is how we can, this is the parameter list we can have for such function. So you can see we have A and B, and then when we put C in the parameter list, because we know that C is used to store the merged A and B, so the length of C should be the length that's of A and B, so we should add the length of A by length of B and then use it as the length of C. So this is what we can do for the parameter list for such function. So the other advantage of writing the parameter list like this is again, it can help the readers know that these parameters are used as the length of the array here, so it's more descriptive. So it's easier for others to understand your functions. However, even we write down something like this, there's no additional error checking, so it's still possible that an array argument is too long or too short. So this is an example here. So if you write down something like this, you can see that although we have a length of 10, right? Then if we call the function like this and use C to store the merged result A and B, but you can see that the original declaration of C only have a length of 10. So if we forgot to increase the length of C before we use it in the function code, you will still have error in your function. So it is still important to make sure that the array argument you provided here have the sufficient length for the function code. And this variable length array parameter is useful for multi-dimensional array. So for example, we can have this revised sum array here. So this function we introduced in the previous example can help us to summarize the elements in the 2D array. So we can rewrite the parameter list like parameter list from this one. Sorry, from this one. So in the original versions, we say that we need to provide the number of column, right? But in these revised versions, we can just, so in this revised version, we can make this 2D array as variable length array. So in this case, we can also use the second parameters as the length of columns for array A. So in this case, we don't need to fix the number of column for this function. The number of column can also be the variable length array. Okay, so that is all about how to use variable length array parameters and what is the benefit of it. So in the next slide, I want to switch to the next topic, and this topic is about compound literals. So I want to use this example here to show how to use compound literals and why you may want to use compound literals. So here is the example we saw a lot of times. That is the sum array function when we have the main here. So in this case, I have an array B. So B is 1D array, and I initialize B using initializer like this. And then I just use sum array to sum all the elements in B. So here I provide 5. So that will be all the elements in B. So in this case, if B is not needed for any other purpose, maybe for this example, I just create B so that I can get the sum of this list of integer variable. So if B only appears once here, it can be annoying to create an independence like array B only for the purpose of calling sum array, right? Maybe in this case, I just want to sum the multiple number all together, but this series of integer number will not be used in the following lines. So if that is the case, C provides I would say convenient way to simplify our code. So in this case, we can use compound literal to avoid this annoyance of declare and array just for the sum. So we can actually write these lines here, this expression here. So this expression altogether that I use it in bold, 2T here, are called compound literals. So you can think about compound literal like an unnamed array, that is array without a name. So we can create a compound literal by simply specify which elements this compound literal contains. And then we can just use this entire expression as the argument for the array parameters. And the length of this unnamed array is determined by the length of the element we have here. So we can write down compound literal into two types. So here is, we can specify the length of the compound literal here, but we can also omit the length because C can tell the length of this compound literal by the number of elements we have here. So we have 1, 2, 3, 4, 5. We have 5 number here. So you can choose either of this version in this case. So if you check the information we have in the compound literal, you might find that the compound literal is very similar with the case that we use the cat. We have the cast here to an initializer. So this parenthesis here is like a cat. It's like a cast we introduced in the basic type, right? So we can use this cast to do type conversion. So in the compound literal, the parenthesis part is serve as have a very similar purpose with cast. That is, we can convert this initializer into an integer array. And then we just write down the syntax we use to indicate that this name of A is an integer array. So we can write down the int and then bracket here to indicate that the following expression should have the type of 1D array, that is integer array. And then we can just provide the initializer here. And in fact, in C, the compound literal and initializer obey the same rules. So we can also use a designated initializer in the compound literal here. So in the second line, this is another example of compound literal. So this compound literal can be used to represent a 1D float array. And then in the second part, the initializer part, I can use designated initializer. So this will make this compound literal have the element 0 to be 1.0 here, and then the element 4 will have this number here. If you still remember for the designated initializer, if we don't specify the value in the initializer, by default, all those elements will have a default value 0. So that is like the compound literal we can create. So following the rules I mentioned, we can have the compound literal like this. We can indicate explicitly that this compound literal have 10 elements, but we can only provide the initial value for the first 2 elements here. So if we have the compound literal like this is the same for any like 1D array that we have 10 elements, but only the first 2 elements have an initialized value, and the rest 8 elements will have the value 0. And so this is another use of a compound literal here. So the value in the compound literal in the initializer part can be any legal expression. So we can write down the arithmetic expression here in the compound literal like this. This is also a legal statement you can write. Okay, so let's check out whether you guys understand the compound literals and then use array as a parameter for the function. So please read this function carefully here. So we have the same sum array function, and what I change is that now this function will return the floating point value instead of integer value. And then parameter will be the length n, and then the array will be the float 1D array, that is A, and this will be basically the same with the previous example. And for the main function, here I have a function code for sum array, and for the second parameters, I use compound literal instead of another 1D array. So the Slido question will be, what is the output message of these programs? So I will give you guys some time to think about this. Okay, so let's go. So what is the correct output of the program above? So let's see whether we can get 40 summations. We still need 10 more, or maybe 40 is too much. I believe we can reach that, okay? Still need 4 more. Okay, 3 more. Okay, who will be the last one? 1 more. Okay, thank you so much. So okay, let's check out the result. Okay, so interesting. So actually the correct output is 1, not 5. So let's check out why. So actually the reason is that we have some details here. So if you still remember, for the array need to start from 0, right? So if we have the index number 4, that means that this is the 5th element in the array, right? But in the sum array, I tell this function the length of this array is 4. So that is why this array will just sum the first 4 elements. So this sum array will not see the 5th element we have here. So this 4 will not be added into the return value of sum here. So that is why the output is 1 instead of 5. So this is, I will say this is something that if you don't pay attention to, you will get a lot of these bugs in your code, because you need to always remember that for the index number 4, this is actually the 5th element in the array. So always keep that in mind. Okay. So let's go to the final topics for today's course. That is how we can terminate our code. So first, I want to introduce more things about return statements. So like we introduced before, if we have non-void function, so non-void function means that this function must return something. And then we just put down the type in the before the function name. So if we have the type in front of function name, that is non-void functions. So if we have this kind of function inside the body of this function, we need to have a return statement to let the function know what value it should return. And the general form of the return statement is pretty simple here. We just write down return and then add any expression here and then the semicolons here. So again, like the average function, we have return here and we specified what value this function should return. And then the expression follow return is often just a constants or variables. However, we can also provide a more complex expressions. We can also have this conditional operator here as the return value based on the specified conditions. So this is all legal return value. So if the type of the expression in the return statement doesn't match the function's return type, so that means that if we create a function, like in this case, I want to return int value, but inside the function body in the return statement, what I return is a double value. So if this case happens, what C will do is to do the same implicit type conversion. So it will just convert the return value of this expression into the return type of this function. So in this case, what this toInt function will return is an integer value, even although what we put in the return statement is a double value here. So this is what return can do. And return statement can also appear in the functions, and the function whose function, the return type of the function is void. That means that the return can not only use in the non-void function, we can also use return in the void functions. So, and then if we use return the void function, we don't need to provide expression after return. So the reason why we want to use return in the void function is mostly for the float control. So that means that if we use return in the function, this can serve as the breakpoints of the functions. So like in this case, if the input value, if the value of I is smaller than 0, this function will want to just finish this function code without printing anything. So if I want this function to have these behaviors, what I can do is to put the return here. So if the value stored inside I is indeed less than 0, then this line of return will be evaluated, then this function will be terminated without calling the printf in the printInt function. So normally, we all know that at the beginning of this course, we say that we have a very important function called main, and please always remember to write return 0 at the end of the main function, right? So that is why the main function is also a function, and the return type of this main function is int. So in the return here, so when we reach the line of return 0 here in the main function, our program will be terminated. So actually the meaning, the value of 0 here is have some meaning in our computer. So if the main, so what the main return, the value we put is here are called status code. So the status code will be tested by our computer when the program ends. So if a program terminates normally, the main will return 0, just like we have put this here. However, we can also write down other return in main to indicate the abnormal terminations. So if we want to say, if we can check out some situation to make the main function to return other status code, so that we can check if our code are terminated normally, or there are some like special situation happen to make our programs terminate abnormally. So we can use this status code in the return to check that. So that is why this is always a good practice to make sure that every C program you write return a status code, because it is I will say I will say if you have a chance to develop a large size of C programs, to have a status code can help you debug this large size of C program in the future. So that is important. And you can see that in this case, actually we can also have a parameter list in the main functions. So we can actually to like kind of input some value when we run our C code, when we run the exe files. So we can use these two parameters to get the information from the command line. But I will not introduce it right now, but we will introduce it in the later course about how to use these two parameters. Because you can see we have the star symbol here, so must have something to do with pointers. So that is why we will introduce how to use this after we introduce pointers. So after I introduce how to use return to terminate our programs, let me introduce another way to finish our code, that is exit functions. So running a return statement in main is one way to terminate our programs. Another one is exit function. But if you want to use exit function, you need to include another standard library, that is std_lib here. So you need to add one more include directives here. And then we can write down exit like this. And exit is a function. And so we need to have a parenthesis, and we need to provide arguments in the parenthesis. So the argument passed to the exit function has the same meaning as the main's return value. So if we want to indicate that these programs terminate normally, we need to pass 0 here. So we can rewrite our main function like this. We can write down exit here. So the meaning of 0 here sometimes is hard to understand. So actually the meaning of 0 means that this program is terminate normally. So actually C also provides some macro definition for the status code. So you can actually write down the macro like this as the arguments for the exit function. And also C have this exit value, exit success. They have a lot of macro for different status code. So if you are interested to learn more, you can check out the macros defined in this header file. So if you write down something like this, you can check out some like the printed message here. You can see that after you program print what you want to print, there are always some lines here, right? So you can see that because this program finished normally, you can see we have the exit code 0 here. So that is what we designed here. So here I designed that in this code, we say that if this code is terminate normally, I want to return the exit code that is 0 here. And actually the value of this macro is implementation defined. So what this means is that the actual value for this macro may be different from one machine to another machine. So typically there will be value of 0 and 1, but if you truly want to know what is the exact value of these two macro, you can also check out the header file here. So the biggest difference between return and exit is that exit function will cause program termination regardless of which function calls it. And return statement only ends your programs when it appears in the main functions. So we can check out the two examples here. So in this example, I put exit here. And in the example in here, that I just put the return here. So if you run this example in our computer, you will see that when your lines, when we call the test function, and when the exit function is evaluated inside the test function, although it is inside the test function, your entire program will be terminated. However, if we run this, because the return value is in the test function, so what will happen is that we will finish the code of test function properly, and then this message will be printed out, and then the function will be terminated. And in this case, the hello world message will not be printed out because the function is terminated at this point. So that is the biggest difference between exit and return, and you should keep this in mind if you want to use exit function. So actually that is all for today. So we introduced a lot of like small topics in today's course, but they are all about how to use functions and how to use array with functions. And that is all for today. And so please keep in mind, if you want to check out your exam sheet, please come to my lab during this time. And that will be all. Thank you for coming today.